Let's recap. Let's recap what we have done so far. Um, let's recap what we have done so far. Since we have started with chapter 3, let's reflect what we have done so far. One, we covered matrix notation. That is the first thing that we have done. Two, you know how to estimate. You know how to estimate the coefficients. In multiple linear regression and interpret them. You know how to estimate the betas given by this formula in matrix notation. Agree that is given by the inverse x prime y. You know how to do this, and I said you can also write this by using what? Small letter b is also the same as this one. 3. So the reason why I'm doing this, I'll be surprised if one next time asks me what is the scope for the test. So if I'm telling you what we have covered, 3, you know how to test for overall model. You know this one, when you test for the overall model, we use what? When testing for the overall model, we use the ANOVA table. For testing for the contribution of each independent variable, you know how to test for the contribution of each independent variable by using this method. We agree that one, by using what? Can you come in now? Which method can be used to test for the contribution of each independent variable? Which method can be used? Yes, leadership.
The partial F.
Thank you, leadership. Partial F test. Another method, leadership.
Confidence interval.
Confidence interval for the betas, for BIs. Yes, right. The third one. We have 3. The third one. Leaders, help the other leader, please. What is the third method that we have used to check if the independent variable is making any is helping us to predict y. What is the other variable? What is the other method that can be used? It's fine. For the sake of time, we also spoke about what?
Is t-test.
The t-test. So I said, those who attended last week, I said I can ask you a question to test if a certain independent variable is helping us to predict y, but I ask you to use one of these methods. Let's assuming that I'm specific that use the partial F test to test. You cannot say no, I don't know the partial F test, but I know how to use the t test. If I'm specific that use the partial F test, you have to use the partial F test. Same applies to the test yesterday. If you are asked to use the maximum likelihood, you cannot use the least square method because the question says use the maximum likelihood method to test. 5. So if you didn't you missed some of our tests, make sure that you go back to your study guide or recorded notes and find this. Try to look for this information. 5. 5. 5. It will take us back to number 5. It will take us to back to what? Estimating the coefficients in multiple linear regression. But some of the independent variables are categorical. Categorical, meaning that the variable is not numeric. Number 5 is what we have covered last week. But if you recall what we have done with Mr. Chabalala, you also managed to do what? What we have done with Mr. Chabalala, simple linear regression. He asked you to find what? To find coefficient of determination. Remember, he told you to find this. So the procedure is still the same. How do you find the coefficient of determination? You know it's SSR over SST. So this is what we're going to cover. 7. We have done the partial. We've done the partial F test, which implies that we'll be able to calculate partial coefficient of determination. So these are some of the things that we're still going to cover. So this number 7 is related to partial F test. It goes with the partial F test. Since you know how to do the partial F test, I don't think it will be difficult for you to understand how to find the partial coefficient of determination. Again, from simple linear regression, you know how to calculate and interpret coefficient of determination, which is R squared, which is talking about the variation in y that can be explained by the two independent variables, that can be explained by the independent variable when you're dealing with simple linear regression. But when you're dealing with multiple linear regression, it means that you'll say the variation, whatever is happening to the y, can be explained by those independent variables. So understanding the definition is very, very important before you can even go to an example. Same applies to partial coefficient of determination. So before we can move to these two, last week we covered dummy variables. On Friday we covered what is called the dummy variables. But I only gave you a situation where that independent variable is having only two options. I gave you an example in a case where that independent variable is having what? Is having two options. Like the one that we have done, it was about you want to buy a house, but that house, you have another variable that you wanted to know from that data set if the house that you want to buy is having a swimming pool or not. We discussed that for approximately 45 minutes. Uh, but if I recall very well, the attendance was not good at all. So my advice, leaders, I know now you're under pressure. Um, test after test. I know it's not easy. So please, I'm begging you guys, don't dodge classes. Please, even if you know you are writing maybe around 6, just try to come to the class, because now, last week, if I recall very well, I was having only 36 students. And according to the register, you are 303. But only 30 came to attend our Friday class, which is not good at all, leaders. That's why I'm aware that you are under pressure, but I won't encourage you to dodge classes, please. Let's recap what we have done last week concerning the dummy variables, also to help those who were not there. But I will encourage you guys, don't repeat what we have done last week. Let's call it a mistake. It was not intentional. Let's call it a mistake. You didn't come to class. You made a mistake. You admit from now on, guys. Don't make sure that you, whenever we're having a class, you come to class, please. So last week, what we've done is that we covered what is called dummy variables. Dummy variables. Those who were in class, let's recap, and also to help those who didn't come. Dummy variables are represented by 0 or 1. And I indicated that 1 in most cases is assigned is assigned in a case where you are indicating the presence of something. One is assigned. Oh, sorry, there's a repetition here. I didn't see that. Let me remove. Let me remove this. Let me remove everything. So yeah, okay, it's fine now. I said one, the one here. In most cases, it represents the presence of something. 0, the absence of something. Let's just give an example when coming to that one. Last week, we were having a question which was talking about why it was the price of the house, x1, it was the size, x2. X2 was what, guys? It was the swimming pool or it was x3? X2, yeah, x2 was swimming pool. Swimming pool was represented by yes if the house is having a swimming pool, no if the house is not having what? A swimming pool, and so forth. So now we change this to what? Wherever we see a yes, we try to put a 1. Wherever we see a no, we put what? A 0. So in this case, 1 present that the house is having what? A swimming pool. 0 represent that the house is not having what? It's not having a swimming pool. But there will be cases where it doesn't matter which option is assigned to 1, which option is assigned to 0. I gave an example of gender. Gender, there's no rule that we should always assign 1 to male and 0 to female, or the other way around. So it's up to you that which one do you want to make 0, which one do you want to make it 1. But in a case where you're talking about the presence of something like the one that we're doing now, if the house is having a swimming pool or not, yes, it means the swimming pool is there. 0 means the swimming pool is not there. So in this case, you cannot say yes is represented by 0, no is represented by 1. Is it clear, guys? Because now I want to move to a case where you are having 3 options. You are having 3 options. So let's come up with examples where one can have a variable, but a categorical variable, but is having 3 options. So now let's go back to our example, maybe the last example. We have the selling price, we have the size of the house, we have the age of the house. Age of the house. Let's think, guys. Can you please give me a variable that's related to the price of the house, but that variable, we can have more than 2 options under that variable. Let's think, guys. The swimming pool is having 2 options. Can you please come up with a variable? Let me help you. Let's bring this new variable, a variable which is categorical, and we call it what? The location. Location. What can we have under location? What can we have under location? Please unmute your mic. What can we have under location?
Rural.
Rural. Let me write it down.
And suburb.
Suburb. Let's have more than 2 options? You said rural, suburb. What else? What else?
Town.
Village
Township. Yes,
or
village. It's
village.
fine. So thank you very much. Thank you very much. If you can check now, we have under location. Under location, we have four options. Four options from the leaders. They said rural, suburb, township, village. Now, remember this one is supposed to be what? This is X1, this is X2. But now, this was supposed to be what? X3. I'm saying it was supposed to be X3. But because of these options, we have more than two options. This option, this variable here is going to create more variables. So now, when dealing with, now our focus now is on this X3, but this X3 will be changed. So you have to let now. So when coming to the dummy variables, the first thing that you have to do is to have what we call what? What you call a reference variable. Since we have four options, it's four, no? Yes. Since we have four options, we must choose one option. Or maybe before we continue, what is the difference between rural and a village? Can't we change this village to something? Rural and a village, I think that seems like it's one thing. Can't we change one of these two? Guys, where are you coming from? You won't tell me that all of you are coming is either from the rural, suburb, or township. Where are you coming from?
Lokshi.
Lokshin is not township. It's different. It's a different thing.
Squatter camps.
Yeah, squatter camps. So let's go with the squatter camp. SK, squatter camp. So I want to change this one to SK because I'm using SK because already we have the suburbs there so that you can see the difference. So now, since we have four options, we must take one of these four options to be what? To be a reference variable, e.g. SK. SK, let's say we say SK is our reference variable, which means now we'll have what? We'll have X3, which goes with what? 1 if rural, 0 otherwise. So let's understand this statement. I'm saying you are X3 now. It means whenever you see X3, it means X3 goes with what? X3 goes with X3 goes with if the house is located in a rural area, or 0 otherwise. If the house is not in rural area, it means it's what? It's either in a suburb, in a township, or in a squatter camp. Now we'll have another variable now. Like, can you please write under this selling price? Now we have X4. 1 if,
Sir,
yes, the house
what,
from the suburb.
what did you write there
Yes.
at the bottom?
Well, you cannot see.
Yes.
Is it because of the screen? So
No.
let me remove everything. Okay. Let me write again. We agree that we have a variable. Now it's fine, leadership.
Yes.
Leadership. You said the third one, it was what? Or township and SK, squatter camps. So I said, because this variable is having 4 options, we must take one from the 4. Before you change the other ones, you must select one as your reference variable. In most cases, we take the last option as the reference variable. So now this one is our reference variable. Now, since this one is, we're calling the reference variable, it means now we have to, when you don't ask, please guys, stop me. I will project the notes immediately after this. So now this one, it will be x3. This one will be x4. This one will be x5. So now our model is started with what? Price equal to B0 at plus B1 size plus B2 age plus B3 rural plus B4 suburb plus B5 township. You see, if you can check from number B3, if you can check, I didn't include what? SK. I didn't include what? I didn't include SK. Which means now your data set is affected. What is going to happen now? What is going to happen now? It means your data set will have Y, X1, X2, X3, X4, X5. So it means your data set before you involve the dummy variable, change these dummy variables to numeric. It was what? It was having only Y, X1, X2, location. Remember, this one is age. This one is size. Under location, you're having what? You're having 4 options. So those 4 options, they changed to what? Now, X3 is what? X3 is if the house is in a rural area or 0 otherwise. So when you go to your data set, whenever you're under X3, when you see the location as rural, you'll put 1. If the location is not rural, you'll put what? 0. Wherever it's not rural under X3, you'll put 0. You'll put the zeros. But if it's rural, you put 1. Same applies to X4. If the house is from the suburb areas, there's no way that you can have 1 under X3 and 1 under X4. Let's say you cannot have this situation. You cannot say the house is from a rural area, at the same time the house is from the urban area. If you are saying the house is in a rural area, it means the other options is what? The other options are zeros. Same applies to X5. You will put 1 wherever you see township, 0 otherwise. If the house is not from the township, when we're under column 5, you'll put a 0. I have an example that we're going to do, which is related to what? To whatever I was explaining here. So it means X3, if I can go back to the X3, it means 1 if the house is from a rural area. 0 otherwise. Same applies to this one. 1 if, suburb, 0 otherwise. Township, 1 if township, 0 otherwise. The SK, we don't assign it to anything. This is the rule of the dummy variables. X, the last option, you choose as it, you use it as a what? As a reference category. Whenever you interpret, so this one, make sure that you write it somewhere. If you have noticed, x3, beta 3, beta 4, beta 5, they're from what? They're all from location. Whenever you interpret this beta 3, you must reference squatter camp. Whenever you interpret beta 4, you must reference squatter camp. Whenever you interpret beta 5, you must reference squatter camp. Because that is why we call it what? A reference variable. Whenever you interpret the other 3 options, you must reference the squatter camps. But when you are interpreting the age of the house, it has nothing to do with the squatter camp. When you're interpreting the size of the house, it has nothing to do with the squatter camp. So you can only reference that variable provided from what? That variable is from location. So let's go to an example now based on my explanation. Unless if you need clarity before we move to an example.
Sir,
Yes, leadership.
when you say we must reference to the ref variable, how do you reference it?
That's what I'm saying. That one will when I explain, when we do an example, it will be easier what I'm talking about. It's like saying, let's say you want to interpret the beta for x3 leadership. Leadership who was talking?
Oh,
Home. Okay, leadership home. Let's assuming that I want to interpret beta 3. Beta 3 it goes with rural, isn't it home? So you'll say,
yes.
suppose that the beta for rural is positive. Assuming that the beta for rural is positive, you will say holding constant the effect of the other independent variables. It means you are holding constant the effect of size, age, suburb, and township. When the house is from a rural area, it will sell more than, let's take the value, it was what? It was 1.2. The beta 3, maybe it was 1.2. You will say that holding constant the effect of the other independent variables, you are referring to size, age, suburb, and township. When the house is from a rural area, is expected to cost so much compared to a house which is from a squatter camp. Did you get it, Homo?
Oh yeah, now I get it.
When you buy a house from a rural area, assuming that our beta 3 is positive, when you buy a house from a rural area, it's going to cost this much compared to a house which is from what? Which from a squatter camp. Also, when you are interpreting beta 4, you will say that holding constant the other independent variables, when the house that you're buying is from a suburb, from suburbs, you expect the house to cost so much compared to a house which is from what? Squatter camp. Remember, I explained that whenever you interpret beta 3, beta 4, beta 5, you must talk about the reference variable. We go to beta 5. If the house is from a township, it's expected to cost a certain amount compared to a house which is from a squatter camp, holding constant the other independent variables. But now we're going to an example. I think that example, it will make our life easy. Now allow me to close this. Allow me to close this. I want to share the notes now.
So, sir,
Yes.
if we have 0 for all those variables, it means the house is in the squatter camp.
Sorry. Yeah, correct. If we have zeros, it means we're coming to that one because I think it's a good question in leadership. Suppose that how do we I suppose someone want to buy a house from a squatter camp. How will the person estimate? How will the person estimate what the what the price of the house? We're going to that one. Thank you for that question, leadership. So I prepared this question last week. Last week we've done this one, isn't it? We've done this one, but remember we changed this to what? We changed this swimming pool. Swimming pool. I shared the what? I will share this notes immediate during break. Leadership class rep, remain with me during our break so that I can share these notes. So those who missed our class last week, I prepared an interpretation of a dummy variable. How do we interpret it? So here's the interpretation for those who missed our class last week. I changed. Initially, the question was about fireplace, but I changed it to swimming pool. So now I showed you how to interpret that independent variable. So here's an example, guys. Here's an example. I'm not sure if you can see this information. This data set is about the starting salary of graduates who graduated from those streams. Someone graduated from physical science, someone graduated from engineering, and someone graduated from what is the other option? Accounting. So the first column there is talking about what? The starting salary. I will give you the statement. I missed it when I was bringing this question here. I will give you a statement which goes with this data set, but it's exactly what I'm saying. Here you want to predict the starting salary based on the GPA and the stream, or what I can call it, the degree that the person was doing. The person who was doing physical science stream degree, someone was doing engineering, another person was doing what accounting. So if you can check under the discipline, we have 3 options. So now based on my explanation, let's change this to what? Because we know the first one here is what we want to predict. This is our y. We're fine with this one. Grade point average, this is x1. It's numeric. So now if you check your categorical variable now, you have a dummy variable here with how many options? There's physical science here, there's engineering, there is what? There is accounting. So under this variable we have what? 3 options. Can we have an agreement? Let's take one of these options to be a category, a reference variable. Which one can we use as our reference variable?
Engineering.
Someone saying engineering. Yes, leadership, Tato?
Accounting.
Accounting. There's someone saying accounting. But it doesn't matter. But in most cases, I said the last option can be used as what? As a reference variable. But even if someone uses engineering, it's not a problem. But when you're given a question in a test, I'll give you direction that for you to have same answers, use this one as your reference variable so that we can have what? A similar, same answers. So let me check. I want to check what I've done here. Yeah, okay, it's fine. What is going to happen? I have the answer for this, but what's going to happen? We're saying use accounting as what? Reference variable. We're going to use accounting as a reference variable. So now let's change. I want to check if you understood what I was saying. I want to create two columns here. On the right side. So this one we agreed is x1. I want to insert a column on the. Sorry, now some of my buttons here are not functioning. So I cannot even see what I'm looking for. Oh, it's fine. Here it is. All right. I want to insert two. All right. So it's your time, guys. I want to check if you understood what. So it means our x2 will go with what? Physics. Physical science. And x3 will go with engineering. So let's go. Give me the information now. What am I supposed to write under the first row? Under physics. What am I supposed to write there?
One.
Yes, leadership. 1. Waiting for the answers.
1.
One.
I'm told that is 1 again. Yes.
1.
One.
Yes.
1.
Yes.
1.
Yes.
0.
0.
0.
Yes.
0. 0.
And I come
Until the last one. 0.
until the last one. Thank you very much. It means under x2, whenever you see physical science, you'll put 1, otherwise 0. Same applies to engineering. Engineering, what do I do here?
0.
0, 0, 0,
0.
0,
1,
1,
1.
1, 1, 1,
0, 0, 0, 0, 0, 0.
zeros. Thank you. You see? So it means initially we started with what? It looked like we're having only two. Seems it looked like we're only having two independent variables. But now, because we have these two, we cannot use this one, isn't it? But we must bear in mind, we must understand what is the meaning of our 0, what is the meaning of our 1. So now, whenever you run a model, it means you are going to run a model without and make this one. Sorry. So this column is out, isn't it? Whenever you fit a model, you will fit a model without the red part, isn't it? Now, what you're going to use this one as your variable. GPA, X2 will be what? Will be this physics part. X3 will be engineering. X3 will be engineering. Sorry. So you're going to use GPA, X2, and X3 because you converted this one, which was categorical, to numeric. So whenever you run the model, you only going to use these three. I repeat, whenever you interpret physical science, you must reference what? You must reference accounting. Yes, leadership? Yes, I'm listening. I thought there's a question. Someone want to ask a question?
Says it a break.
I don't know. Is it a break?
What time is the break?
I don't know. I'm not the timekeeper. I have my timekeepers here. Why are they? They're not here. Are they not here?
They are quiet.
So it means not a break.
It's 8:20.
So this is what we have now. It's fine. Just give me 2 minutes. We'll go at 8:20. Give me the last this 1 minute. So now you will have this data set. Where do you interpret now? We agree that X, you check this part. I'm going to share this note with you guys. Don't worry. We agree that the accounting discipline is called a reference variable or a default condition, which means that whenever you interpret the physical science, you must reference what? The accounting. Whenever you interpret the engineering, you must reference what? The accounting. So here's the interpretation, which is similar to what I was explaining earlier. But there's a leader who said, what about if someone want to buy a house from a squatter camp? So it means when you want to estimate for a house from a squatter camp, it means for X2 you'll put a 0, and for X3 you'll put a 0. And then by doing so, you'll be estimating for a house from a squatter camp. So here's the interpretation of the question. I will also include this type of a question for tomorrow's tutorial so that you can practice on how to interpret categorical variables, especially the coefficient. Because after this step, the ANOVA table, you do it the normal way. The t-test, you do it the normal way. The only difference is when you interpret the betas. But if I ask you to construct an ANOVA table from this stage, there's no way that you can fail to do that. So let's go for that break, a 1 minute break. No, sorry, 5 minute break. I will end the class at 9:05. So I'll give you your last 5 minutes at the end of the session. So we can break for 5 minutes. When we come back, we'll cover coefficient of determination and partial coefficient of determination. We'll do that after break. Thank you. So let's break, Homo. Let me know when it's 27 past 8.
Okay, sir. Sir. Sir.
Thomas? Yes,
Yeah. You can continue, sir.
thank you. So, uh, let me share those notes again. I don't know what's happening now. So, one of your tutorial questions, I'll give you this question. This question, see this question, question 2. I'll give you the inverse. Um, I'll give you the what? The inverse and x prime y. I will ask you to continue with what? With this question. You find another table. You apply the partial f test. Everything that we have covered so far, I will ask you to do the same here, but using matrix notation. And again, I'll ask you to, I'll also give you this one, because I want you to get used to categorical information. But the only part where you have to be careful is when coming to the interpretations of the betas. When I was joining you when we started with chapter 3, I said interpretation is very, very important. Whenever you calculate something, you should be able to explain what is the meaning of what you have calculated. But it seems like we are not at that stage of understanding the meaning of whatever you have calculated, which is it's a problem. It's a problem because after next week we'll be doing some practicals. Practicals now, you'll be expected to interpret, because now if I give you a model like this, you should be able to interpret these betas. And whenever you interpret the betas, relate it with what? With the given problem. For example, if I ask you to interpret x1 with the GPA, you see the value here for x1 is beta 1 is 5.491. You cannot say holding constant the effect of x2 and x3 when x1 is increased by 1 unit. X1 is increased by 1 unit, y will increase by 5.419. What is that 1 unit that we are talking about? Is it not there from the statement? If it is there, please indicate it, that my 1 unit is 1000. My 1 unit is 1 floor, or is an additional floor. My 1 unit. So please indicate the unit of that independent variable if it is there from the statement. You can say 1 unit provided from the statement it is not given, it's fine. But if it is given, indicate the unit. That when you say, when you increase something by 1 unit, what is that 1 unit? Indicate it as, because it is given from the statement. Don't generalize things while when they're given, please. So now I think I've covered. So there's another question that this one is your task. You will do it whenever you are free. This question is for you. Let me even change here instead of saying, yeah, it's task 4. Task 4, you can go and try it. Wherever you are having some challenges, you can consult me. What is happening here? You are given x1, which is continuous, x2 categorical, x3 categorical, x4 numeric, x5 categorical. You must understand this is related to dummy variables. So please go and try this example. Wherever you're getting some challenges, we'll discuss. So now allow me to go back to the study guide now. Allow me to go back to the study guide and let's cover the other sections which are still hanging there. If you have noticed, since I've started, I didn't cover the confidence interval for the mean and the prediction confidence interval. But we'll cover that. So allow me to go to the study guide. I want us to calculate coefficient of determination and interpret the meaning of that coefficient of determination. You know the formula. I think the question which is related to that was there in your yesterday's test. Coefficient of determination and partial coefficient of determination. These are the two things that we have to calculate. From there, we can move to selection methods in the afternoon. Yeah, then I don't want to. Let me close this. So can you please go back to the class example? Let's go back to the class example. Let's go back to our class example. Remember the one which is talking about the selling price of the house, the age, and the size. Let's go back to that example. We need it now again. We need that example. Let's go. Class example. Give me the ANOVA. Give me the ANOVA table of the class example. Omu, do you mind?
Degrees of freedom of regression, it was 2, 17, 19.
Yes.
There you have 2258, 80618. That thing was 114, 19382.
Yes.
Then you have 2373.
Can someone confirm the values, please, before we continue? Can you confirm the values from the class example, please?
Sir,
Yes.
for regression, I have 2261. Sir,
43. Hey guys, can you hear
Sir,
me?
yes, we can.
Yes, it was network. Now I was trying to reconnect, but even Mr. Chabala will be joining us in a few minutes. So I think instead of discussing something with you in the afternoon, he will discuss whatever I want to discuss with you now. So uh, let me try to do that. I was asking about the values. Someone said the values from Momo are not correct. Can you please let's continue?
Yeah, there is a mistake there, sir. It's
Yes,
2261, comma
two
four
two
six.
six. And then the error.
Sir, are you displaying something?
Yes, there's nothing.
Yes.
Oh, sorry for that. Uh, sorry for that. What about now?
Yeah, is there?
Is what the error now?
Leadership title said 111, comma 53989.
1 1 1 1
53989.
and then MS. So I need remember it said 6 point something. MS. This one is what? The numerator is what? What is MSR? Just divide, guys.
1130.
And now when you guys you are not talking, I thought my net 1130 F. Give me F. It's fine. Give me F.
0.71. 1130.71.
Oh, 0.71. F. F is what? I cannot see what you are writing.
172.271.
172. So when you're busy with simple regression, Mr. Chavala taught you how to find R squared. He said it's SST over SSR. So we're going to use the same formula in multiple linear regression. Nothing is going to change. So what is your R squared? So please find the R squared and interpret. Find R squared and interpret it. Remember, now we're having what? We're having two independent variables. When you're dealing with simple regression, we're having only one. Can you please give me that value and interpret? Or give me the definition of R squared. What does it measure? Give me the value, please. I cannot see the what we are writing.
Sir, that
Yes,
formula.
Sir, the formula is
yes.
wrong.
Sorry, the formula is wrong. Give me the right formula. Then the numerator is supposed to be the denominator, isn't it?
Yes.
Oh, sorry. Erasing everything now. SSR over SST, which is what? Based on a given problem.
Uh, 0, comma 95299.
Fine, it's fine, Omu. Interpret the value, please. Mr. Chabalala, are you in?
95% of the variation is explained by the model.
Yes, Mr. Malek.
Okay. You
Thank
can
you.
hear your leaders when they try to interpret the R squared.
I'm listening. I'm listening.
Yes. Can another person come in?
95% of the variation is explained by the model.
I heard you, leadership. I want another person to explain in a different way. There is a definition from your study guide. There is a definition from your study guide. Relate to that definition from your study guide. What does it say? Under coefficient of determination. Can you please check your study guide? Just check under coefficient of determination. I'm not saying what you are saying, leadership, is wrong. But I want someone to explain that in a different way. Can someone read the definition from the study guide? So leadership, who's playing Manalo songs, please relax. The coefficient of determination, here's the definition from the study guide. Coefficient of determination measures the variation in y that can be explained by what? By the independent variables. In our case, we have independent variables. The variations in y is the proportion of the variation in y that can be explained by your independent variables. So based on that statement, please, you know your independent variables is what? Is from class example is size and age. These are xi's, and y is what? Is price. Is price. So I'm saying the variation in y measures the variation in y that can be explained by these two independent variables. So what can we say about this 95%? 95% of the variation in the selling price of the house can be explained by what? By these two independent variables. That's what we are supposed to say. Go to the study guide and check the general definition and relate it with this 0.95. In the afternoon, we'll do the other R coefficient of determination, which is related to the partial F test, and we'll move to the selection methods. Before we do the confidence intervals for the mean and for the prediction interval, we'll first deal with selection methods, which is I think from my study guide is chapter 5, but we have to bring them in because they're related to whatever we're doing now. So, Mr. Chabalala, how many minutes do we need? We still have how many? 15 minutes. Do you need 15 minutes or you need less? Or it's not enough?
No, I need, for now, I need less than that because of, I want to hear from them. So I'm not sure
Okay.
if they have a lot to share, but I feel like 15 minutes, it's a lot.
It's fine.
You can,
You can talk to them. It's fine. And then if you need if you are done before time, I can continue. Otherwise, you will have another slot if you want in the afternoon. So time is
Okay.
yours. Yes. So I can close this.
Good morning, guys. How are you? Good morning. How are you?
Fine, sir.
Good morning, sir.
We're good, sir.
I'm good. I'm good. Are you guys angry at me? What's happening? Why are you not responding? Are we fighting,
we're
guys?
still
What's happening?
we're still unmuting mics.
Okay, okay. How was the test?
It was too much.
What do you mean by too much? Too much what? Too much marks? Too much free marks? What's happening? What do you mean by too much?
You were giving us many things for less marks. Like me, that one year likelihood is what 4 marks. It was supposed to be maybe around 8 or something, so that we can pass.
The question that we are talking about, unfortunately, majority are not getting it. The highest from question 1 so far, I think, got 11 out of 20. Majority are getting 1. So I'm here to address that because we are concerned. We have marked more than 50% of the scripts, and we can confirm that less than 20 from that 50% have passed. So it's concerning. That's why I'm here. So we want to hear from you. What's happening? What was happening there?
Yeah, those things were main. We couldn't finish. You didn't give us time to think about the test because those questions were main.
Can I please come in? Can I please interrupt you there? Let me take you through the questions. You will tell me what you mean by the time was not enough. The first question, question 1, A, was true or false. There's nothing to complain about there. You read the statement. If the statement is true, you say true, you give a reason. If it's false, you give a reason. Then you go to B. That's where you have the question of the maximum likelihood. You have this question from the study guide. The only thing that I did was to replace by beta 0 by 10. People are still writing the model with beta 0 because they've memorized. So you don't know what you're doing. It was not the matter of time, but let me progress. The second one is checking whether the estimator is unbiased or not. Then maybe you can say you need less than 10 minutes to drive the maximum likelihood, because what you need there is to write the likelihood function. You write the likelihood function, you take the log of that, you differentiate. You cannot say that you need 10 minutes to differentiate the likelihood function. From where I am, without opening anything, I know the likelihood function of a normal distribution. So you have a normal distribution. What you need to do is to replace the mean, only the mean, by 10 plus beta 1x. That's the only thing that you were supposed to do there. You go to your notes. What you are having from your notes, what you need to do from the likelihood function is to replace the mean by 10 plus beta 1x. You are failing to do that. You are failing. They are like, when you say you needed 8 marks.
No, the test was fine. Say there was no problem with it, but the marks were not allocated like correctly. Say,
how do you want marks for every step?
Say give us marks. Say we want to pass.
On which question? On which question?
Okay, you are saying use the maximum likelihood to estimate beat, and that thing require many steps. You should give us
Mr. Malek, Mr. Malek, if you allow me, can I please project the memorandum?
Mr. Leadership Chabalala.
Yes, leader.
So if they're saying the marks were not enough, we can multiply the test to be out of 110. And wherever is 2 marks, we make 4 marks. And we see if...
I wanted to... Thank you, leadership. I wanted to come to that, but I wanted to show them something because
Yeah, you
if
can
we do
project,
that,
Mr. Chairman.
No, don't project anything. We were.
no, I want because you are saying the marks were not enough. I want you to show me the steps that you feel like they deserve the marks and they are not allocated marks. So I want you to show us that step. Maybe we'll know from today that
Okay, it's
we
fine.
have
Okay,
to
you
adjust
can
things
project.
like this.
You can project.
Yes, I will only project the
Guys,
maximum likelihood. Don't worry, you won't see the other things.
you
All
must
right.
understand one thing, Mr. Chamalala is here to understand what is the problem. We are not fighting, guys. We want to help
Even
you.
myself, I'm not fighting. I'm just saying the
Yes, so
marks were not
understand that part, guys.
allocated
We want to
correctly.
help you.
Thank you, Mr. Maleke. Can I proceed? Christopher, I will recognize you. Give me a minute to explain this. Now, you have the likelihood function. You have the likelihood function. So having the likelihood function, a correct likelihood function, you get a mark for that. You cannot say you want the mark for taking the lien. You didn't do anything there. There is no mark for that. You have the correct partial derivative. You get a mark for that. You have the correct partial derivative. You have a mark. For equating this to zero, you cannot say you want a mark because after getting the partial derivative, you equate to zero. You cannot say you want a mark for that. Now, you divide both sides by this constant here. You cannot say you want a mark for that. You didn't do anything. Now, you simplify this term, you get a mark. Removing the brackets. Are you saying we should put marks here for removing these brackets? Then from there, after removing the brackets, everything is clear. You take the part to the right and then the other ones to the left. Then it's the final answer. So
Yes.
which steps deserves the marks here?
Sir,
Saying that
the marks. Okay, go up, go up, go up.
up where?
Out.
Up where?
Out.
It starts here.
Yes, for knowing the maximum likelihood function, give us the marks.
No,
there.
you cannot. It's more like giving you a mark for writing a formula. You cannot
I agree, you didn't
demand a
give us
mark
the
for
formula.
that.
Fella, you didn't
No,
give us the formula.
let me put it like this. This is how the memorandum it's